Hello, welcome to section 2.4, matrix operations. So basically we're just going to do addition and subtraction with matrices, and we're going to maybe multiply by a number, a scalar multiplier. So matrices, we talked about that a little bit in class. The capital letters of the alphabet are usually used to denote a matrix, and capital A, and then after it there'll be a couple of numbers. Well, the first number represents R, which is a row, and then there'll be like a little X, and then C, and that stands for columns. So the way you read this is it's a matrix, and it's so many rows, and then the little X means by so many columns. Now, columns are like on a building. Columns go up and down, and rows go left and right. So that kind of makes sense. And it's row by column. And the way I helped you remember this the other day in class is that there's Coke is a cola, Pepsi is a cola, and then the other cola that nobody remembers is RC, which stands for Royal Crown Cola. All right, so I'm going to write a couple of things here. Let's make the A matrix 2 by 3. And I'm just making up an A matrix, and typically you use these bracket things. And then I have 2, 7, 8, 4, 9, and negative 2. So there's the A matrix, and it's 2 rows and 3 columns. Does that make sense? 2 rows, so row 1, row 2, and then 3 columns. Switch to another color. Columns go up and down. 2 rows, 3 columns. Now the individual numbers in here are called elements. All right. Then the A matrix is 2 by 3. Let's make a B matrix. The B matrix is, we'll make it 3 by 2. So this one, instead of looking like a hamburger, this one will be tall like a hot dog. So we'll make this one taller, and it'll be skinnier. And we'll do 2, 4, 7, 9, and 8, and negative 2. So notice I use the same numbers, but it's going the other way because it's a 3 by 2, so that means it has the 3 rows and 2 columns. So it just flips it the other direction. Now, for operations, we're going to do addition and subtraction. Now, to do that addition and subtraction, the elements have to match up. So if we try to add these two matrices together, you're like, okay, let me get out my highlighter tool here. We're like, okay, well, this is in row 1 and column 1. Well, that matches up row 1 and column 1. So you could add those together. 2 and 2 is 4. And then, I'll pick another color here. We'll do green. And we're like, okay, well, that's the still the first row, second column, first row, second column. So that matches up. You could add those together. But then not good stuff happens, right? So I'll change that to, I guess we'll do like a purple here. That means like warning. Well, I thought I picked purple. Let me undo. There we go. Now I picked the purple. And I was like, okay, well, that's in the first row, third column, first row, third column. And then this is, wait a second, there's nothing there. There is no first row, third column. So you cannot add these together. It's impossible because the dimensions don't match up. So the elements have to match up perfectly by row and column. So if you do matrix A plus matrix B here, there's no solution to that because it has to match. And I think that's pretty obvious. You just match them up in the rows and columns. So matrices are used to hold a lot of information in a small space. And if you look in the book, you'll see some examples of how they took a lot of information about like, you do the days of the week and the number of items that are sold, and you can like put it in a matrix, and okay, on this Tuesday I sold so many candy bars of this type, et cetera, from your movie theater booth or whatever. Okay, new page. So example 1 here, we're just going to subtract two matrices. Now this one here, everything's going to match up perfectly. So example 1 is subtract. Example 1, we're going to subtract the two matrices. And the first matrix, I'm not going to give it a name, I'm just going to 2, 0, -5, 1. And the reason why I'm doing subtraction with you is because addition is way easier. You don't have to worry about distributing the negative sign. All right. So let me color code this again. Let me get my highlighter tool. So we'll put the first row, first column, all that stuff, and then the green matches the green. And switching colors here, we'll go back to the blue matches the blue, and I'll throw in the purple, and the purple matches the purple. So everything matches, so we just have to subtract those colors, and then that's our answer, piece of cake. So it's 2 minus 7, that's -5. So there's my resultant matrix. And then it's going to be 0 minus a -4. Well, it's a double negative, so it's just 4. And then it's -5 minus 1, which would be -6. And then it's 1 minus 8, which would just be -7. So that's the answer. And it's really that easy. Okay, now we're going to do a scalar multiplier. So if we have to like double all the numbers or triple all the numbers in the matrix, it's really easy to do. So example 2 is a scalar multiplier. And if we have a number in front like 4, and we have 5, 9, and -2 and 8, all you're doing is just multiplying everything by 4. So the new answer would be, obviously, 20, 36, -8, 32. So everything just got multiplied by 4. That's it. That's it. Now, where are we going with this? Well, what happens is you kind of put some of these concepts together. So there's some homework problems here that I want you to try. And some of them combine some of that stuff together. 49 is kind of that way. Problem 49. So if we look at problem 49, I want you to do 49. But let me just give you an example of what that kind of looks like. So this is from the homework here. 49, it defines A as the A matrix is a 2 by 2 matrix, 1, 4, -2, and 3. And then it defines the B matrix, and it defines that as 0, 2, 4, and 1. And it defines a C matrix too. But, if you had something like this, this is actually part C, and it's 3A minus 2B. So you have to follow the order of operations. So no matter what you do, no matter what math you're doing, you always have to follow the order of operations. So you're going to do 3 times the A matrix, 2 times the B matrix, and then you're going to subtract the two of them. So it would look something like this. 3, 12, -6, and 9. Hopefully I did that right. So I multiplied everything here by 3, all the parts in there. And my math is correct, I believe. Yes. Then it says minus, and then you're doing all the parts here by 2. So you have 0, 4, 8, and 2. And then you would go ahead and subtract them. But the idea is you can do multiple things with matrices. You can do this one times this one, or not times, but this one plus this one, plus 3 times another one. But the main thing is the dimensions have to be the same. Notice this is 2 by 2 and that's 2 by 2. So they'll be able to add together. Alrighty, so woohoo! That is basic matrix operations. Multiplication of matrices is trickier, and it's its own section. So the last section that we'll do before the test is multiplication of matrices.